The aim of this session is to try and work through some good evaluation points for the working memory model, so this is aimed at AO3. Okay, first of all, when we look at the model, we can look at some supporting evidence for it. For example, Baddeley and Hitch performed dual processing tasks in order to test the claims of the model that there are indeed separate stores involved in processing information into short-term memory. Basically, what they would do is they would give people tasks to do simultaneously, and that task might either be focused on one system, or it might have one task focused on one system and the other on another system. In doing it this way, they found that the tasks that used two systems within the model tended to be performed more effectively than the tasks that used just one system within the model. Okay, further support for it is for the idea of the inner ear, and it's really to do with the fact that it has got limited capacity, because research which tested recall for long words compared to short words within the short-term memory found that more short words could be recalled than long words, which is suggesting that there is a limited capacity because the longer words took up more room within the phonological store than the short words did. Coming over to the inner eye, and we'll start to look at some evidence that supports that. It's the idea that we can help to explain dyslexia fairly effectively by taking on board this model. If we look at the inner eye as necessary for learning to read the visual printed words from a page, and we look at perhaps there being some kind of mismatch between that and the articulatory loop and being able to hear and see the words, then we might be able to come forward towards some explanation for dyslexia. However, on the negative side with the model, we've got evidence from researchers which shows that people who have been blind since birth still have a very good ability to navigate their way around space, which, as they lack the visual information to create the visual spatial scratchpad, doesn't really fit with the model very well. So it suggests that the model does have a bit of a blind spot just here, no pun intended. Okay. Looking at it more fully, then we could look at the model as having some problems with its scientific credibility. For example, the episodic buffer. This was added later to allow for anomalous findings to be accepted within the model. So things were happening in experiments that couldn't be explained within the model without the episodic buffer, and they put the episodic buffer into account for that. But it means that it's not clearly defined, and therefore we don't really know what its parameters are, which means that it's not a very scientific way of explaining short-term memory. And the final point that we might want to bring in here is the fact that this model, whilst it's a model of short-term memory and it's not intended to explain long-term memory, it does not explain the transfer into long-term memory, and that is a bit of a problem with the model. Unlike the multi-store model, which is quite clear and shows the transfer between stores, this one doesn't show any transfer between stores, and that might be a limiting factor of the model. But on the whole, when we look at the model, it probably explains a lot more than the multi-store model does, and it's certainly more in tune with how our memory works in the real world.